Hello viewers, this is Wagdaru now taking you through this tutorial for A-level applied mathematics. And this video, we're going to talk about the topic of motion in a Cartesian plane involving variable acceleration. So this topic is in mechanics and is suitable for students in senior 5 and senior 6 offering principal mathematics as part of their combination. So motion of this type, where acceleration is variable, involves use of calculus. By calculus I mean differentiation and integration techniques, and also use of Newton's second law of motion. So both we shall see how they are applied in under this topic, but let's start with the case 1 for using Newton's second law of motion, which says that F is equal to ma. And with that we shall look at this example, which was got from UNEB 2011 paper 2 question 2, and it says a particle of mass 2 kilograms moves under the action of 3 forces F1, F2 and F3. So this is force F1 in terms of t. So at any time t, force F1 is this. I think you can see that force F1 is a function of t, meaning it is variable. I and j. F2 is also a function of t. That means that F2 is also variable. And F3 is also a function of t. That means that F3 is also variable. So when you see this t, just know that it is now a variable force. Now they say that find the acceleration of the particle when t is equal to 2, and that is 5 Mach. So you shall come and see and say that the resultant force is equal to the sum of all the forces. So you shall come and sum up all the forces, so F1, F2 and F3, to come up with t minus 3i and 3t minus 6j. So now that I've got the resultant force, I can use that with Newton's second law of motion, which says that F is equal to ma, and when I make a the subject, I'll come up with F equal to F over m. Now 1 over m is this one, so m is 2 kilograms and the resultant force is this. Therefore, with that I'll have got acceleration in terms of t, but remember they ask for acceleration when t is 2, so I'll come here and say that when t is 2, acceleration will be equal to, so I'll substitute 2 here and also substitute for 2 here to come up with negative 0.5 and 0 meters per second. So basically that's what they wanted in part A in this question, and now let's see how mass can be awarded. So M1 is for you to add up all the forces, and A1 is for you to simplify to get the output. Then B1 is for you to get the acceleration as a function of t, and M1 is for you to substitute the value of t. A1 is for you to get the final output. So now we shall go to the next case, where we need now to use the differentiation techniques. Now in this case, we shall use the formula that velocity is equal to the derivative of displacement, or displacement from origin. So therefore V stands for velocity, R stands for displacement from origin, and T stands for time. So V will be equal to the R dt. Whereas when it comes to acceleration, we shall say that acceleration is equal to dv dt. Remember, acceleration is the rate of change of velocity, and therefore it will be dv dt, and while velocity is the rate of change of displacement, which will be the r dt, where r is displacement. So differentiation techniques require you to remember these two formulas, that v is the derivative of displacement and a is the derivative of velocity. So with that knowledge, you shall now do example 2, which came from UNEB 2002 paper 2 question 8, and it says a particle moves in the xy plane such that its position vector at any time t is given by r, which is 3t squared minus 1I plus 4t cubed plus t minus 1j. So how do you know that is variable? You know that's variable when there is t in the expression. So I think you realize that r is a function of t. That is enough proof to show you that it is now, you are now dealing with variable parameters. Then part A says that find its speed, and part B find the magnitude of acceleration after t equal to 2. Now this one, I think we realize that now this one has been put after putting part A and part B, meaning that they want the speed after 2 seconds and also the magnitude after 2 seconds. So first of all, we are given r in terms of t, which is 3t squared minus 1 and 4t cubed plus t minus 1. So if I want to get the velocity in terms of t, I'll have to differentiate r. So when I differentiate 3t squared minus 1, I'll come up with 6t. And when I differentiate 4t cubed plus t minus 1, I'll come up with 12t squared plus 1. So basically that is now the velocity at any time t. But they want you to get the velocity when t is equal to 2. So I'll come here and say that when t is equal to 2, therefore I'll come and substitute for t here. Where there is t, I'll put 2, and where there is t, I put 2 to come up with 1249. Now that I've got velocity in vector form, I will come back and remember that they ask for speed. Speed means magnitude. So I'll come at this velocity and get its magnitude, and that will be the speed they want. So speed will be equal to square root of 12 squared plus 49 squared, which will give you 50.4480. I think you realize that there is no unit here because there are no units given in the question. So basically that's what they wanted in part A. Now let's see how mass can be awarded for part A before I go to the next slide. So M1 will be for the derivative, B1 for the velocity vector, substitution and output, and also A1 for magnitude. Now we shall go to part B. Part B they wanted, for part B, they wanted magnitude of acceleration when t is equal to 2. So I'll come here and say that acceleration is the derivative of velocity. Therefore acceleration will be got by differentiating velocity. When I differentiate velocity, I'll come up with 6 and 24t. And when t is equal to 2, I'll substitute to come up with acceleration being equal to 648. But they ask for magnitude, so I have to get the magnitude, which will be 6 squared plus 48 squared, everything under root, to come up with 48.3735. And there are no units. So basically that's what they wanted, and now let's see how mass can be awarded for this part. So M1 will be for substitution and getting this acceleration in vector form, and A1 is be for getting the magnitude of the acceleration. So that has been case 2, where we need to use the knowledge of differentiation. Now we shall go to case 3, which requires the knowledge of integration. So remember, integration is the reverse of differentiation. Therefore, if to get A acceleration you differentiate velocity, it implies that to get velocity you have to integrate acceleration. Similarly, if it is true that to get velocity you have to differentiate displacement, then it is also true that to get displacement you have to integrate velocity. Therefore, that's where the two formulas come from, that v is equal to the integral of a dt with you integrate a with respect to t, and also r is equal to the integral of velocity with respect to t. Now with that knowledge, you shall be able to get the solution for example 3. So now example 3 came from UNEB 2014 paper 2 question 2, and it says A particular car starts from rest at the origin 0, 0, not those two words, rest and origin, which is 0, 0. Its acceleration in meters per second squared at time t seconds is given by a being equal to 6ti minus 4j. Find its speed when t is equal to 2 seconds, and they give it 5 Machs. So first of all, we know that acceleration is equal to 60 negative 4. Therefore, to get velocity, I have to integrate. So when I integrate acceleration, I'll integrate 60 to come up with 3t squared. Then I integrate negative 4 to come up with negative 4t. But don't forget the constant of integration. And this constant is also a vector, so you should not forget this tilde symbol here. Therefore, when t is equal to 0, initially it implies that velocity was 0 because they told us that the particle was at rest. And when I substitute for t and for v, t here 0 and I substitute v here, which is 0, 0, I realize that I remain with c being equal to 0, 0. Now that I've got the value of c, I can now come and express the velocity without a constant of integration, which will be velocity will be equal to 3t squared and negative 4t. Now that I've got velocity, I'll come here and say that when t is equal to 2, velocity will be got by substituting for t. So where there is t, I'll put there 2 to come up with 12 here, and where there is t here, also I'll put there 2 to come up with negative 8 there. So now that I've got velocity, I can now come and get my speed, which will be the magnitude of velocity, and it will be equal to the square root of 12 squared plus negative 8 squared to give me 14.4222 meters per second. So basically, that's what they wanted, and now let's see how much can be awarded. So M1 will be for integration, and B1 is for the velocity function with no constant of integration. So this M1, the constant of integration, has to be seen. B1 is for substitution and output when substituting t is equal to 2. M1 is for you to substitute in the formula, and A1 is for you to get the output which they want. So basically, that's how the 5 Machs could come about. So now we shall go to example 4. And example 4 came from UNEB 1995, paper 2, question 8b, and says a particle of mass 2 kilograms initially at rest at 0, 0, 0 is acted upon by a force 2ti plus tj plus 3tk. So because f is a function of t, it implies that it is variable. Then Roman 1, they said find the acceleration at 10 times t, but Roman 2, the velocity after 3 seconds, and Roman 3, the distance traveled after 3 seconds. So we shall start with Roman 1, where they want you to get the acceleration. Now, since you have force, you will come here and say that acceleration is equal to force over mass, where mass is 2 kilograms and force is 2t, t, 3t. So when I simplify, I'll come up with t 0.5t, 1.5t. I can also express in terms of ijk by saying ti plus a half tj plus 3 over 2 tk. So basically, that's what they wanted in Roman 1, and let's see the marks for Roman 1 before we go to the next slide. So M1 was for substitution, and A1 is for the output. So now shall go to Roman 2, and Roman 2 says find the velocity after 3 seconds. So now that velocity will be got by integrating acceleration. So acceleration was a half 2t, t, 3t. So when I integrate this, I'll come up with this a half here will remain here. Then when I integrate, I'll put this will be t squared over 2 and this will be t squared over 2, this will be t squared over 2. So this will be t squared over 2 times 2, and this one t squared over 2, and this one t squared over 2 times 3. So the denominator is pulled out to bring this a half, so that I remain with 2 here, 2t squared, and remain with t squared here and 3t squared here. Then plus the constant of integration, which is t(c), but it has to be in vector form. Then next I'll look for I'll remember the initial conditions. I would solve that initially the particles at rest, meaning velocity is 0, 0, 0. Therefore, when I come and substitute for initial velocity, I'll come up with c being equal to 0, 0, 0. Therefore, my expression for velocity at any time t is a quarter of 2t squared, t squared, and 3t squared. Therefore, when t is equal to 3, I'll come and substitute for t. Where there is t, I'll put there 3, and I'll come up with a quarter of 18, 9, 27. Therefore, I can substitute, I can write in terms of ijk, and it will be 9 over 2j plus 9 over 2i plus 9 over 4j plus 27 over 4k. So basically that was Roman 2, and now let's see the mass for Roman 2. So M1 will be for integration, and B1 is for the velocity function. In this integration, the constant of integration has to be seen. Then this M1 is for substitution, and this A1 is for the output. Now we shall go to Roman 3. Roman 3, they want the distance traveled after 3 seconds. So the first thing to do is to get the displacement. So displacement will be got by integrating velocity to come up with a 1 over 4 times 1 over 3 2t cubed, t cubed, and 3t cubed plus c, where c is the constant of integration. So when t is equal to 0, initially the particles at point 0, 0, 0, which is the origin. Therefore, when I substitute, I'll come up with c being equal to 0, 0, 0. Therefore, my displacement from origin will be 1 over 12, which is this. A quarter times 1 over 3 gives you 1 over 12, and this one to give you the displacement vector. Therefore, when t is equal to 3, I'll come and substitute for t to come up with my displacement being equal to 4.5, 2.25, and 6.75. But remember, they asked for distance. Therefore, I have to come and get the magnitude of that displacement, and therefore I'll come here and say that distance traveled will be equal to the magnitude, which is square root of 4.5 squared, 2.25 squared, and plus 6.75 squared, everything under root, to come up with my distance as 8.4187. So basically that's what they wanted in Roman 3. And now let's see how marks can be awarded. So M1 for integration, this mark for the displacement. For integration, the constant of integration has to be seen. Then this M1 is for substitution, and this one is for the output. Then here M1 will be for substitution and A1 for the output. So basically that's what they wanted. So that brings us to the end of this video. So what I'm going to do, I'm going to leave you a set of questions still on motion in a Cartesian plane involving variable acceleration. that brings us to the end of this lesson. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with the solutions has been uploaded. Otherwise, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.